Alrighty, guys, what is up? Welcome back to another episode of The Farmer Was Replaced with Lone Debater 7. And today, we're going to be showing how to set up sunflowers. Before we do that, we're just going to cover a little bit of progress and give an update from last time. If you look up here, I have a lot more resources. I have kind of generated quite a bit and upgraded the yield for our hay, our carrots, our wood, and our pumpkins quite a few times. I almost have the watering maxed out, almost have the size maxed out. So we are playing with the 16 by 16 farm at the moment. Um, but I want to set up sunflowers today. That kind of feels like the next step because given the size of our field, um, it takes a very long time for the drone to move through it to actually like harvest the stuff. So if we get sunflowers set up, basically this will allow us to increase our speed. With that being said, last time we kind of were having this issue where our program would kind of time out periodically when doing pumpkins. So the reason for that is basically the while loop that I had above, and then the like weird if statement checking down below was not the right way to do it. Instead, I need to run an if statement at the top of the while loop that just does our normal calls. And I also increase the increment amount to 5,000 from the 100, I think is what we started at. So this has seemed to work pretty well for me. It doesn't really time out as far as I have noticed. Like I've generated quite a bit, it hasn't timed out. Um, Only other thing to mention, I did shorten this and did optimize our build a little bit. So I noticed while you're running trees, you technically have half of your field available that you could be planting grass inside of. And if you do half trees, half grass, you actually end up stacking pretty well. So instead of running a specific just plant the whole field grass program, I now, if I need wood or I need hay, right? If I need either of these two, I just run my trees program, which gives me both of them. So, yeah. And this is kind of what that looks like. So it checkerboards it with trees and hay, and it works pretty well. That's why I have quite a bit more wood than anything else because whenever I need hay, I also get a ton of wood from the trees that I'm harvesting at the same time. But all right, enough of that. We'll let this run while we kind of set up sunflowers. But that's what we're going to do today. We're going to set up sunflowers. Um, and how do I want to? What do I want to call this? I think we're going to call this PWR for power, and then we're going to define Sunny as the program, and it's probably going to take in RP for request power as an argument. And then we'll look at trying to get this guy done. So there has been an update, so I am actually getting Chiefs for the stuff I'm doing now since the full version is released at this point. But let's unlock sunflowers. 500 carrots, easy. We have 91,000. That really broke our bank. Lol. Uh, all right, so let's kind of read through this and see what we're getting into here. So sunflowers get power. You harvest the power. Planting them works just like carrots or pumpkins. It's basically the same as our pumpkin program. We'll talk about that. Harvesting sunflower yields power. If there's at least 10 sunflowers on the farm, and you harvest the one with the largest number of petals, you get 5 times more power. So worth harvesting the largest. You use measure to return the number of petals of the flower onto the drone. Sunflowers have at least 7 and at most 15. They can already be measured before they're fully grown. Several sunflowers can have the same number of petal. There can also be several sunflowers with the largest number of petal. In this case, it doesn't matter. As long as you harvest the largest sunflower on the field every time, you get 5 times more power for the harvest. So, what that means is we basically need to A, planting the field is easy, right? We've set up programs for that for 3 other crops. It's the exact same thing. We're going to have something to the effect of, um, a loop this. We want to, if can harvest, plant sunflower, and then go from there. What does it actually cost to plant sunflowers? Does it say here? It doesn't. What we can do, though, since we have all this resource, I think I want dictionaries, and then I really want this get cost so I can see how much various crops cost. So I can use this function. It returns a dictionary. Okay. So it'll be items doc. Okay, so it'll be the item name, dictionary cost, or entry cost. Okay. So I can also use it for upgrade cost. Okay, interesting. Okay. I mostly want that so I can check the cost um, for sunflowers. Okay, so I need carrots in order to do sunflowers. Interesting. Fun times. Okay, we'll delete that one out. That's fine. That's kind of what I figured. We're going to need to set up carrot checks. So basically, our sunflower program is going to look very similar to our pumpkin program, right? We're more or less going to track our number of plants we're going to do like a planting cycle, then we're going to do a harvesting cycle. The plant cycle is going to be plant the entire field. We have to verify we have the whole field planted. If the whole field is planted, then we go through and check like every flower in the field to get a measurement of do you have the most. And like we can maybe make that efficient where if it is 15 petals, we know it can be harvested immediately, so harvest it, right? Because that's the max count. But if it's any value less than 15, we basically want to throw that inside of like a list to keep track of, okay, at this tile we had a flower with this number of petals. Keep track of that, and then once it scans all of the flowers, right? So our tiles or number of tiles based off of our world size, when we've scanned that number of sunflowers or harvest them, right? So if it's 15 petals, we still need to like track that inside of a variable. So maybe not in the list, but whatever, that's fine. And then we can harvest. So, okay, let's do this. First things first, we're going to want like a loop variable, I think, in this case, so we can start and stop this potentially. We want a can harvest. We'll can harv, I think is what we'll do, which will equal false initially. That way we can split it into planting stage, harvesting stage. So flowers the plant, harvest is the harvest. Makes sense. Petals is going to be our list object or dictionary, whatever. Then we're going to do a variable for our dimension. So sunflower dim. We'll just set it a random number of like 5. Call it a 5. So while our flower variable is true, we're going to run this loop. And this loop is going to be basically we want to check our x position and our y position and utilize that to populate into this variable up above. We could have populated that as 0. It doesn't really matter. If our get y is greater than this dimension, then I want you to take that dimension variable and put in our get position y. Whoops, not what I meant to do. There's that. Then it's going to be if the ground, yeah, so we do need to till for this. If ground type does not equal grounds dot soil, then I want you to till. If our get entity type And so this can return none if it's an empty tile, so we want to check that. Or if that entity type is not a sunflower, we want to plant a sunflower, right? So entities.sunflower, cool. There's our if. So at this point, if we can harvest, because there's something inside, we want to harvest that plant, right? Cool. Then what we're going to do is if our num items of entities.carrots is less than or equal to, I think I need to do it the other way. It maybe doesn't matter. Less than equal to, it's basically going to be cost of entities.sunflower, but I need to return the variable inside, so I probably should throw in do I so like I'm gonna return this, but like I want to access a variable inside, so I more or less need to run this command to populate a variable is what I need to do. So we'll just call it SFC for sunflower cost, and that is going to be cost entity sunflower. That's going to return it as a dictionary and put it inside. That's totally fine. I'm trying to decide if I want this inside or outside. The cost should be fixed, I'm pretty sure, unless we upgrade the thingy mid execution, which could happen. So we'll populate the variable inside the while loop. I know we don't really need to do that, but like it should be fine up here in almost every instance. This is a very edge case bug that I'm trying to prevent. So we do this. Fine. So from our SFC, I basically want to access the entities.caret that is inside of it, like that. And I believe that will work. Oh, whoops. I do need it after. Okay. Cool. That's just the error for having a statement. Baller. I'm pretty sure that works. So, if our carrots are less than equal to the cost of not entities carrot but sunflower, uh, wait, no. We're populating SFC with the cost of sunflowers, and then we're looking for the cost of carrots. So if our carrot cost, yes, okay. If this works, now I need to import our carrot. That way we can call in that, because basically what we're going to do is, okay, we need more carrots. So I really need to run the harvest loop, and then I need to also plant carrots. So um, I'm just trying to decide if it's worth. It's fine. So like this brute force way that I'm doing here, and that's not actually what I want. I want carroty. Oops. There we go. And then this requires 2 arguments. Just requested amount. Okay. So that is going to be SFC entities carrots. And there we go. Basically what this guy is going to say, if we have less than the required carrots to buy a sunflower seed or to plant a sunflower, right, we are going to run our carrot plant program and pass in the cost of a carrot seed. And really, we can maybe make this more sophisticated than that. Cost of carrot seed times if we do like double world size, so for like the size of the world, we're going to end up putting that variable in anyway. And honestly, it might make sense to say if our caret count is less than the cost times the double world size, or the number of tiles, right? So we'll go ahead and populate DWS, which is going to equal get world size squared, which is times 2. Yeah. So now we need to have the cost of caret times the double world size. So I actually need to do this and then times DWS. That should work. And why am I doing it like that? Is it like that? It might be like that. What do you mean? Oh, do I not have enough? I don't have enough. Okay. Fair enough. Okay, cool. So that works. Amazing. There's no compile errors, so I'm pretty sure that is running our plant or our check for carrot seeds. So what we need next is the elif. Basically check same condition but greater than instead of less than equal. Boom. As long as this is greater than, then I want you to plant our sunflowers. So it's more or less going to be the same. Yeah, if it's none, not sunflower, then harvest, cool. Then if it's greater than, I want to go ahead and plant our sunflower. And after we plant the sunflower, we're going to run our wet program, so I need to import that. Cool. And this is going to be wet dot water, right? Cool. Then from there, we want to, I guess we'll implement the scan. So I am just gonna, well, what are we doing here? Because I need to more or less, this plants everything, this will plant the whole field, and then I need to scan it. So like, I can run measure before the plant is fully grown. So at this point, I think what I need to do is build my list, or start populating my list with the petal count, because we're going to run our measure command and then put that inside of our list. So how do we do this? Basically, what we're going to say is if the length of our list, which is just saying how many entries are stored inside of it. So if that equals 0, so it's the first time we're running this while loop, what I want you to do is petals, not pet the piggy, but petals, dot append, add an entry, and we are going to measure the tile where we just planted this sunflower, right? And we're going to put that inside of our list as a new entry to our list. Cool beans. Now, that's if it's the very first tile. If it's not the first tile, so literally every other time, I want it to do this. I want it to run a for loop where we go for I in range of length petals. I think I need one. Two? Just two, not three. 4 petals. Cool. If our petals at the index of I, so the number of times we've run the loop, is less than equal to our measure. So basically it's not the first entry. That means there's something to compare to. We compare it to the last value or some number of values, right? So what we want to do is for every value inside of our list, we want to check every entry in our list. And if the measure of the current tile is greater than or equal to that value in the list, what we're going to do is we're going to go ahead and insert into that list at position I, so the number in the loop, and the value we're going to insert is the measure. So basically, if this value this is going to help basically like sort our list based off of greater to less than to greater than is what this is doing. So then for the other side, we need to also measure the length of petals, right? Easy money. -1 because it's going to be 0 indexed, right? And we're doing a count, so we need to -1 to offset or accommodate that. Easy peasy. So petals.append, and throw in another measure. So if I equals length petals, so if it's the last scan, what we want to do is measure. So, okay, basically, if the index, right, for the number we've run the loop is less than or equal to our current tile, we're going to put this one at this index in the list. If it's any other case, so if the index value is greater than the measured tile, then we're going to throw this measured value to the end of the list. So basically, the end of the list will be the smallest, the start of the list will be the biggest, is how this is going to work. If I understand that correctly, it sorts it greater than, equal than is what this is doing. So there is the for loop. The other condition we kind of need to check here is we need to check whether or not we have scanned every tile in our field. Meaning, have we planted the whole field of sunflowers? And if so, have we taken our scans for all of them as well? So the way we do this is greater than equal to our sunflower dimension plus 1 squared is what that's going to look like. So sunflower dim plus 1 is the thing we are squaring. So we want to double 2. Boom, boom. That should work. So if our list length is bigger than double our dimension times 2, then our flower is going to be false. So this exits us out of the scan and planting loop. And then at the same time, what we're going to do is move. We need to move at the end, right? To move us through the field. So we need to import our MV. So we can say, where's the cursor? There it is. That should be in line with this .bmv. Boom, boom. There's that. Okay. So I'm pretty sure this will plant. Now we need to handle the harvesting, which is basically going to look like take our list that we created, start at the largest values, harvest all of those, then do the next largest value, and then every time you harvest something, remove it from the list. That's what we need to do for our harvest portion. So we come in down here. And basically what we're going to say is while the length of petals is greater than 0, I want you to, if the entity is a sunflower, then if you can harvest and our petals at 0 equals the measure. So what this is basically saying is if you can harvest it, so is there a sunflower? Okay, our list is bigger than 0. Is there a sunflower? There is a sunflower. If we can harvest that sunflower and that sunflower measures larger than the first petal in our list, then I want you to harvest that sunflower. All right. So we're going to go harvest, easy. And then we're going to go petals, dot pop, and 0. So what this pop 0 is doing is it's basically deleting so petals is accessing the list. That's our list, petals. We're popping entry 0 of the list. Okay. Then in line with this is our mv.bmv function call. And that should be sunflowers sorted. I don't know that I need a can harvest variable, frankly. I didn't really use it, but that's okay. We'll leave it in there just in case we need to add it later. So there is our function, program, script, whatever you want to call it for our sunflowers. Now we need to figure out the prioritization. So I have reordered this to start with pumpkins, then do carrots, then do grass and wood as a singular. So I think what I want to do is start with sunflowers, then do pumpkins, then do carrots, then do trees and hay. And the reason for that is sunflower will modify the speed and the capability of us to move through the entire field faster, thereby increasing the yield on all the others. So what we'll do is we need to make our mount power variable and our actual power variables and add them in so we can track this. And then our actual power is equal to num items dot power. Cool. Then I need to import in our PWR so we can call the program. Then we add in AMT. Now the only other consideration here that is worth talking about potentially is technically power is not a 1-to-1 ratio. So if we set it the same, 5,000 for power, right? That's not going to give us enough to actually farm all the fields. So I'm thinking what I need to do here is actually multiply it by the size or number of tiles times some modifier. So I'll maybe do that and kind of figure out while I finish writing the if condition here, which is just simply AMT power less than equal to ACT power. Do I have double world size at this level? I don't. So we'll just make a variable for that. We'll call it size tiles at this level. Okay. So there's that. So since we're doing this, it's actually going to be AMT underscore power plus 5,000 plus DWS times. So let's think about this. 5,000 is going to cost I don't know. It's probably going to be, well, we can maybe do math for that. Let's do math for that. So, well, it depends on the yield we get for each item. I think per field we get about 2,500. So we need to do about 2 fields of everything, and there's uh, 3 other crops, so that's 6 fields. But pumpkins also have a modifier, so I think we'll do double world size times like 5 of additional power. Well, let's do it times 10. And really, I'm just trying to think here. So I kind of want it to be equal to these plus this. So maybe what I do instead is I do it as 2 lines and I plus equal the 5,000 first. Then what I do is on the next line, since it will now be at the 5,000, I then add amount power plus, I think I can do a plus equals here and that'll still work. Plus equals our DWS times our modifier. And I think that works just fine. We'll find out. See if we get a compile. And see if that works. This is not a valid expression. Oh, yeah. It also might help if I finish my if. Huh? Okay, so this is going to be AMT underscore power is greater than equal to our actual power. Then I want you to go into PWR dot, what did I call this? Sunny for the function name. And you're going to pass in AMT underscore power as the variable. Oh, whoops. There we go. Is that right? I think that's right. It's only calling for one arg. I'm missing the exit condition for how long to run the loop. So right, because this loop is going while true on that. So there's 2 loops here. I think what I do is I just put them inside of an overarching loop. And I know that this is maybe not the best way to do this, but while RP greater than equal to P. And I know we need to define P, so we'll do that real quick. P is going to equal the num items dot power. Okay. Then I want to basically put these other 2 loops inside of this loop. And I do need to update our P variable. And I think I should honestly update it inside of the plant. Nah, it should be inside of the harvest because I want to plant and harvest the full field every time. So honestly, it's going to sit just outside of both loops. So it'll trigger inside of the primary loop here, but outside of the other 2. So basically every time this cycles, it should check this, and that kind of matches our other programs, right? So like we update our variable just inside the loop down at the bottom, and that's perfectly fine. Works perfectly well. Let's see if we plant some sunflowers. AMT power. Oh, misspelled it. Actual power? What do you mean? Because I misspelled it here. Uh, oh, I didn't call it that. I called it size tiles. Cost has never been defined. What do you mean? That's a defined function. Oh, it's get cost. Lol. I only called it the one time. Forgot the parens. The one argument is entity caret. So do I need different brackets? I think I need different brackets. Are there base squares? I need items carets. I'll come back once I have this figured. All right, so I did figure it out pretty much right away. More or less what was going on is I was checking entities caret down here twice. I needed to change this. Once I got that updated um, to look at items instead of entities, that did fix our program. So if we look at this, we will plant sunflowers. We are hitting an issue here. Petal has never been defined. Okay, so I need to move these definitions into the loop is what it looks like. And that's fine. Just like that. Except for P, because it needs to be initialized. Okay, so what is happening with this? Oh, it's because it's on a sunflower. Uh, okay, so I need to put in something to check if it's over a sunflower. And I guess what I can do is just have it move to keep it simple. So if get entity type Okay, so we're planting, but it doesn't see this. So I honestly need this inside of the flowers loop. There we go. Okay. So we're planting sunflowers. And then this, I did have this as a 0. It has to be double world size because we want to wait until it plants the whole field. So that's what that variable is doing. I just want to make sure that this actually plants the whole thing. Yes, I know I had a syntax error. Sorry about that game. Um, no worries. I think we're going to get it. So like if I look at my, like what's actually inside of that, I'd love to know what the contents were right now. Because if it's getting cleared out every time, then this isn't going to work. We'll see if the harvest works. That's what I'm checking now. I hope so. Be awesome. We have the logic there for it. It's just more of a question of is our list actually getting populated properly? I think that's clearing it out is what's happening. Yeah. Okay. So our issue here is our list variable. If I put it just inside the function, like right here, outside of the while loop, we get the error that it's not defined when it tries to scan. Oh, actually what I need to do here, uh, I need to throw in the loop for our, this little bit needs to go in underneath, or whoops, I didn't want to cut it. I just wanted to copy it, actually. And it's just going to be to this point. That's correct indentation, I'm pretty sure. Except for this. Yeah. The else needs to come back for, okay. So, fair enough. The if goes in line with the else. Let's try that. Yeah, so, oh, oh, Because I'm missing the S. I am so dumb. Okay. That's hilarious, but also kind of frustrating. That makes more sense why it's saying it's not defined, because lol, you're using the wrong name for it, bro. There we go. Look at this. Now we got some items in there. What'd you run into, friends? Um, hello? Why are you getting hung here? Okay, let's do this. Um, I actually don't want to check for the sunflower entity. We shouldn't need it. What we're gonna do instead is run a quick clear command to reset us. Ooh, feels bad. It's fine. We're gonna start from scratch. Run it from scratch, please. We should see our list actually populating with values. Yeah, there we go. I guess it's taking that long because it's checking the entries in the list or something. It must be when it hits like the 11s. Oh, it's because your eye doesn't scale with the number of tiles, I guess. Interesting. But we kind of have to check every value, I think. Otherwise it won't work. You know what I'm saying? Because I can't just say, "Oh, only check this index number." You do actually need to check all the index values. Um, yeah, but I think this will work. So we'll just wait here and see if we once we plant the whole field if we start harvesting. Not too bad though. I mean, pretty compact code, all things considered. I mean, we're more or less just populating a list and then comparing values in it. That for loop is taking forever to execute, though. I must say. Oh, why did the list get reset? This almost makes me think that I have this list set up wrong. Like this for loop should not be so giant, right? That's maybe. I guess it's 256, or well, what's 16 squared? Whatever that is. It might be 256. Somewhere around there. It's 250 something. Or well, if I find my DWS. Yeah, it's 256, so that's fine. It is a pretty big list. And in theory, the power gains from having a whole field and gathering 5 times as much, that should give us quite a bit. Like, we probably need to harvest um, one field of sunflowers, then the next field will go a lot faster because we have power for it. Um, then Uh, it'll probably do like 3 fields of sunflowers to buffer the initial requested amount over the 5,000 is my guess. I wish I could speed up this check, if I'm honest. Like, what might make sense here is mm, I have to think about how I could maybe try to improve that efficiency. I think it's going to work here once we parse through and it switches over to start harvesting. Oh, did I delete my second half of the loop? That's unfortunate. Yeah, it's totally not going to harvest now. Shoot. Yup. Well, that is a crying shame. Um, especially given how long. Okay. I'll come back after I've planted another field and have the harvest logic back in. Sorry about that, guys. Alrighty, guys. So I got this figured out. So the reason why it was taking forever is because it was getting like stuck in this if statement, triggering it for the entire length of the list. Not what's supposed to happen. I needed to put in this break here. So after it detects, oh, I'm at the right place in the list, exit this check. Otherwise, it'll stay here for however many are the same value. So this should work now. The only question mark is whether or not double world size is the correct value. I believe 256 is going to be correct. Length petal should be 256 when it's filled all the way. If not, it's going to be 256. It'll be double world size -1. Um, but we'll find out here once it ticks over. And then I can reintroduce the else if for checking if it's a sunflower on the tile, so it can scan the full field and we don't have to clear it if it happens to not be at the right place for the harvest to kick in. You know what I mean? So it'd be an elif with this statement is what we could do, which basically is going to be the same condition except for not none. It's just going to be entity sunflower, and then we basically just copy this for loop and the move. Yeah, we're going to have to add that. So let's just go ahead and do it. It's not a big deal. It also makes our code more deployable and like uh, less prone to bugs and breaking. So if our get entity type is entities sunflower, or well, actually, I don't want it as an elif. I want it as a secondary check, I think. Or well, maybe I do want it as an elif. It should be in the same condition, right? So like if this condition, run this. If it's not this condition, then this. That's what this is doing. So that's kind of what I want. So I believe I want to copy all of this, paste it in. Yeah, I think that's right. Let's try that. Oh, whoops. So now it should scan and populate the list. And in theory, this should give us... Oh, did I forget the zero index for this? I maybe forgot the zero index for this. Yeah, I need this line as well for the for loop, because that's what actually starts the list. There we go. Now it's getting filled. Perfect. That's what we like to see. That's what we need to see. It's maybe a more apt way of putting that. Let me just slide that down so we can rearrange this. I want to try to help you guys see what's going on. So, and I might ultimately change this with the can harvest variable. So maybe we'll have can harvest goes true when this first becomes true, and then afterwards, it runs the harvest command, popping out the list, and then it sets that false at the end. So petals should be approaching the required length. So it's here. So it's at the required length. It can harvest, but it's not equal to the measure. So I need to put in an else that just has it move. So it'll be MV, BMV, and it doesn't need to be an else. This should happen basically, even if it harvests, it should move. So just put it outside and that should work. It's unfortunate because now it has to repopulate the list again. Lame. Sorry about that, but I do want to see if this guy's gonna work for the harvest or if I'm gonna have to utilize that variable, because I'm kind of concerned that once we pop the entry out of the list, technically our while condition will no longer be true. So yeah, there is that. But this might work in such a way that our um, it'll harvest the one flower and then it'll immediately plant a new one and then it'll proceed to the next largest flower or something along those lines. I think that'll do what we want. I don't know. We find out. Yeah. Towards the end of the field, it does take it a little bit longer because there are more entries um, that it's less than. Okay. So it harvests one. Should get the next. No, it's not going to get the next. It's just populating the list with more. Is that right? Or maybe it should be greater than 0 and can harvest. Um, okay, yeah, we need to change this condition from DWS. That's not going to work. So it's going to have to look at flower. So when flower goes false, so while our length petals is greater than equal to 0, so there has to, and really it should be 10 because you have to have at least 10 flowers um, in order to get the power bonus. So we might as well keep 10 flowers planted. And um, not, or well, really I want to check and flower equals false. Then you run this. And then basically, what I need to do here is inside the loop. I think it has to be inside the while loop. It needs to internally check, is our length of petals actually this should be length petals greater than 10, and then if our length petals is less than or equal to 10, then I want you to set flower to true, because then that would reinitiate our planting process, so it'll plant up the rest of the field, so we'll have more than 10 again. And I think that's what we need here. So it's going to have to rescan and repopulate the array. It'll be one shorter, but that should be okay. Only issue might be it did plant the tile. I guess flower went true, so that's fine. It'll fill the whole list. I was going to say the only issue might be if the list doesn't get big enough. It might not set flower false, but I think we'll be okay. Yeah, sorry. This one got a little bit long. Once we have flowers or power set up with some flowers, it should really really help us here. I don't know that this is correct. This maybe is supposed to be DWS. Ah, there we go. Okay, it's harvesting. Cool. So as you can see, it's harvesting the largest ones out of the list and popping them. So if I can get the list to populate here, it should be doing all the 14s. Ooh, what happened here? Ah, I need to move this move command to the bottom and out here. Shoot. I put it inside of this and I needed to bump it out. That's unfortunate. That's what the issue is, though. So basically, since it's on an empty tile, it won't proceed. All right, fine. Let it continue. We do have some power, so this, in theory, should go a little faster. Yeah. Drone moves twice as fast. Can you scale that any further? Maybe not. It's fine. So it looks like our harvest does work, except for the running into an empty tile thing, but I think this little change here should resolve that. Here we go. Start scanning, start harvesting. I don't know. I guess we could harvest the entire field, right? I think leaving the 10 does make sense, though, for the multiplier on the power gain, right? Cool. Well, it seems to be working pretty well. So I'm pretty stoked about that. While it continues to harvest here, we'll just let that go in the background. I think the plan for the next episode, I kind of want to take a look at going for cactuses next and get those set up and integrated to our little listy up here. So we'll maybe look at that next time. We could try to do polyculture, but I think I want to do cacti first. So we'll do cacti. We could also get our auto unlock and kind of round these out. These are just pumpkins, so it's pretty inexpensive. So like, this is a randomizer, and then it also gives you min max absolute. That's actually pretty good. So we'll unlock that. We'll also get the auto unlock for the farm. So we could automate going through the tech tree at this point if we wanted to. It doesn't take too much, and I mean we could honestly set up a little bit of logic. So as opposed to using these hard coded request amounts that then get incremented, what we could do is build something that checks, hey, where are we in the tech tree and what do we need in order to proceed down it a little bit further. So why not? Let's just drop that on the grass yield again. Might as well. We're getting close. We have another 3 we can push into it. Get time is about time passing. That's cool. So we can check time in game. That's fun. There's simulation. I can't do that yet. I need mazes. This is mazes and dinos. This is mazes. So basically, sunflowers just increase our speed. So this should help us get through the rest of these things a little bit faster in theory. Um, but yeah, we'll go for cactuses next so we can get down to dinosaurs and try to get dinos. Then we'll go for mazes. Mazes are a little bit tougher, in my opinion. So that's kind of the plan. But as you can see, we harvested our first field of sunflowers. It looks like one field gives us about 1,000 power. So that's not terrible. It really does depend on the program and how many actions you're taking, though. So kind of the way power works is every action the drone takes requires one power, and then processing your program also takes a little bit, but it's less than an action. So anyway, guys, if you enjoyed the episode today, be sure to like, comment, subscribe as always. And until next time, this has been Lone Debater 7, and we will see ya.